Hi everyone and welcome back to my channel. In this tutorial we are going to build a complete weather analysis project in Python. By the end of this tutorial, you will know how to take a raw weather data set and turn it into meaningful insights. You will learn core data analysis skills like fixing missing values, creating new features, and exploring trends. You will also learn to visualize your findings with clear and professional plots so you can understand the data and present it confidently. Before we jump into the code, let me quickly show you what the final output will look like. Once we run the program, you will see the daily temperature trend, the humidity trend, the weather condition frequency chart, the temperature versus humidity scatter plot, and finally the full correlation heat map. So this is exactly what we will be building in this project. So this is the weather data set we will be using for our analysis. I will go ahead and copy this data, create a new CSV file named weather_data.csv, and I will paste the raw data into it and press Ctrl S button. After saving the file, I will create a new Python script called weather_analysis.py, and that's where we will write all our code for this project. We will write down this project in 7 steps, and the step number 1 is importing the required libraries. So I will write a command step 1 import required libraries. First I am importing pandas as PD, and pandas is used for loading the dataset and handling all the data in table form. Next I am importing matplotlib.pyplot as PLT. This library helps us create graphs and visualizations for our weather trends. And finally, I'm importing Seaborn as SNS. Seaborn make our charts look cleaner and more visually appealing with built-in styling. So that's it for step number 1, and now moving on to the step number 2, which is loading the file. So first I will create a variable called file_path, and I will type R before inverted commas. The reason for writing R is that it creates a raw string. So Python reads the file path exactly as it is without treating backslashes and special characters, right? Now I will right click on the weather_data CSV file, copy the full path and paste it inside the inverted commas. After that I will write df is equal to pd.read csv file_path. This line simply load the CSV file into a pandas data frame. So we can start working with the dataset. And that's it for the step number 2, and moving on to the step number 3. Step number 3 is basically displaying the original data, and I will write this as a comment here. And then I will write here a print statement to show the original data. And I will do it by using basically 3 functions. The first one is df.head, and head function displays the first 5 rows of the data frame so we can quickly see what the data looks like. Next, I will use df.info. This will give a summary of the data frame including the number of non-null entries and the data types of each column. Then I will use df.describe. This provides basic statistical information like mean, standard deviation, min, max, quartiles, etc. for numeric columns. If I run the code, we can see the first 5 rows of the data, confirm that all 30 entries are present with no missing values, and view the summary statistics as well. In the CSV file, you are able to see 31 entries, but that include one heading as well. So there are a total 30 entries, and all of entries are present. And these are the heading, temperature, humidity, wind speed, etc. And you are able to see the statistical summary that include count, mean, standard deviation, etc. Now there is one more thing left in the step number 3, and that is to convert the date column to date time format. For that I'm writing here df date, and as you can see this is basically our first column date inside of the CSV file. So I will do it basically by using the pd.to_date time, and this makes it easier to work with dates for analysis and plotting. And that's it for the step number 3, and moving on to the step number 4, which is handling missing values. Even though our dataset has no missing values right now, but here I will use df.fillNow to fill any missing values, right? So I'm writing here df.fillNow, and I will set missing values in the precipitation column to 0 because no precipitation is represented by 0. So I'm writing here precipitation colon 0. Then I will put a comma and move on to the next line, and there are wind speed and humidity. For the wind speed and humidity columns, I will fill missing values with the column's mean. And the column mean is basically the average value of the column, which is a very simple way to keep the data consistent without skewing the result. And after the step number 4, now the data is ready for the analysis. And now moving on to the step number 5. Step number 5 is adding new column to the dataset. So I'm writing here as a comment, and I will add basically two columns, month and day. So as you can see in the CSV, we have a column date. Now sometime we want monthly based data and sometime we want daily based data. So we have to make these two more columns. So I will create a new column called month using df date.dt.month. Basically I'm extracting the month from the date column, right? And I will create another column called day using df date.dt.day. This will basically allow us to analyze trends by month or trends by day later on. For example, finding which days are the hottest or which months have the most rainfall. And that's it for the step number 5, and now moving on to the step number 6. In this step, we will basically analyze the data, and we will do it in basically two steps. The first step is about calculating the average temperature and average humidity values, and in the second step, we will calculate frequency of weather condition. So in order to calculate the average value of the temperature, I am creating here a variable average underscore temperature, and I will do it by simply using the dot mean function. And then I will do the same it with the humidity. And let me show you the humidity in our CSV file as well. And as you can see it from here, this contains the humidity as well. So I will go back to the file and I will write here df humidity.mean. And then I have to print the value of the average temperature and average humidity. And I will do it by using the formatted string, or you can say f string. Inside of the curly brackets, I will calling the average temperature, and I want in two decimal values, so I will be writing here .2f. And then I will do the same for the humidity. This will basically give us a quick overview of the typical weather condition in our dataset. So we are done with calculating the average temperature and humidity values, and now moving on to the second one, which is frequency of weather condition. And as you can see in our dataset, we have conditions like sunny, rain, etc. So I will create here a new variable and I will name it as condition underscore count, and I'm writing here df, and I will basically copy this condition from here and paste it over here so that I do not make any spelling mistake. And then I will use dot value underscore counts, and this basically will show us how often it's sunny, cloudy or rainy, and it will give us insights into most common weather patterns. And in order to see those weather patterns, I will print those here. On running the code, we have got this mistake, so we have to place a comma here. And now if I run the code, and these are the weather conditions printed over here. So first I will show you the average temperature and humidity value. So those are printed over here, and these are all the frequency of weather conditions. So these are all printed over here, as you can see in the data set as well. So this basically complete our step number 6, and now moving on to the step number 7. And it is about visualizing the data to make it easier to understand and interpret. So basically we will be creating total of 5 different plots, and the first one is the daily temperature trend plot, and this will show how the temperature changes over time. The second one is the humidity trend, and then the third one is weather condition frequency chart, and then the fourth is a scatter plot of temperature versus humidity, and finally we will be creating a correlation heat map, and that is going to be 5 correlation heat map. First we will create a line plot to show the daily temperature trend, and we will basically start with setting the size of the figure, and this is going to be 10,5, and then I will plot the temperature column against the date column. So I will write here df date comma df temperature and add a circular marker for each data point. So marker is going to be O, and that represents basically a circular marker, right? And then we add a title, So the title is going to be daily temperature trend, and then we have to add labels. So a label for the x-axis and label for the y-axis, and then we will basically rotate the dates for better readability. And for that I'm writing here pl.xticks, and rotation is equal to 45. So 45 is basically an angle. I will show you in the plot, and then finally we will display the plot. So if I run the program and there is an error, so we have to write here figure. Okay, now if I run the program, you will be able to see this chart. And as you can see, the title is daily temperature trend. Temperature are plotted on y-axis and dates are on the x-axis. And this is basically the 45-degree angle rotation. Let me change this rotation first. So I will change it from 45 to, let's say, 10. And if I run the program again, you will notice the angle of these dates. So I hope that you understand about this rotation, or you can say the angle. So I will change back it to the 45 degree. Now I will copy this whole code and paste it for the humidity. The only difference is humidity, right? So as you can see it from here the main CSV file as well. So I will replace temperature with humidity here. Nothing else is going to be changed, although we will make more changes in the next code. So I will copy basically this code and paste it over here for the condition frequency. First I will change the figure size and it will be 7,5. The difference here on the second line is that we will create here a count plot with the condition column, which basically shows how often it's sunny, cloudy or rainy. And here I have written data is equal to df. Basically it will tell Seaborn to look for that column in the data frame named df. Right here we have created this variable earlier. And since this is for the weather condition frequency, so I will remove the previous written title and I'm writing here weather condition frequency. And also I will make changes for the x and y labels. For x label it is going to be condition, and on y label it is going to be count. Next, we are creating a scatter plot to visualize the relationship between temperature and humidity. And I will basically use mostly the previous code, and I will change first the figure size. This is going to be the scatter plot. And here there will be only two values, the value on the x and the value on the y's. On x-axis there will be temperature values, and on y-axis there will be humidity. And I will basically change the title as well. It is going to be temperature versus humidity. I will change the x label and the y label. On x label there will be temperature, and on y label there will be humidity. So I will basically copy this one and paste it over here. And since temperature is displayed in degree Celsius and humidity in percentage, so I will make those changes here and in the previous code as well. For humidity it's percentage, and for temperature it's degree Celsius. And finally we will create a correlation heat map to see how different weather variables relate to each other, right? So I am going to remove few sections, or you can say few lines in the previous code. And since this is going to be the heat map, so I have written sns.heatmap. Then I will go to the dataset and I will copy these four values and I will paste those values here. And since these has to be written inside of the inverted commas, so I will write these inverted commas here before and after of these variables. In order to calculate the correlation between the columns, I am using core, and anode is equal to true basically displays the values of the heat map. And finally CMAP is equal to cool warm, basically colors low correlation blue and high correlation red for easy visualization. And then I will change the title. This is correlation heat map, so I will write that down here in plt.title. There is going to be no x or y labels. And finally, to make all the plots more cleaner and more visually appealing, I am using here plt.style.use seaborn v underscore 8. And now I will run this program. After running the program, a total of 5 figures should be displayed. And this is the first one, daily temperature trend. This is the second one, daily humidity trend. The third one is weather condition frequency. Fourth one is temperature versus humidity plot. And finally, this is correlation heat map. So that's it for this Python project, guys. If you find this video tutorial helpful, then please hit the like button and subscribe to my channel. Thanks for watching. See you in the next tutorial.